Hi guys, today we are discuss about the laser calculations methods of Einstein's A and B coefficients. First of all, introduction of Einstein coefficient like as coefficients are related to the rate of spontaneous emissions of light and Einstein B coefficients are related to the absorption and stimulated emission of light. As we discussed about the spontaneous emission and absorption and stimulated emissions are the rate of spontaneous emissions and the rate of absorption and the rate of stimulated emissions calculation method is known as the Einstein's A and B coefficients. As the diagram of spontaneous stimulated absorption like as to energy state 1 to energy state 2 like as ground state to upper state, spontaneous emissions like energy state of 2 to energy state of 1 like as upper state to ground state. The image shows the very clear definitions. The rate of absorption is given the RAB is directly proportional to rho n1. Likely we know proportional is given a equal RAB it's equal to B12 B of energy state 1 to energy state 2 into rho into N1, and the rate of spontaneous emission is given by RSP directly proportional to rho N2. RSP is equal to A21. 21 means energy state 2 to energy state 1 and rho N2. And stimulated emission of the rate of stimulated emissions RST directly proportional to rho N2. RST is equal to B2 rho N2. As the diagram of energy state, lower energy state to higher energy state, differentiations of absorptions, spontaneous emission and stimulated emission. The coefficients of Einstein's theory, we know the rate of absorption it's equal to rate of spontaneous emission plus rate of stimulated emission. RAB equation it's a B12 into rho N1, it's equal to A21 N2 plus B21 rho N2. In this equation we have to separate the row equations. So we taken a row value of B21 rho N2 to opposite direction. Here we have a positive work. In positive comes in another side it's a negative. So B12 rho N1 minus B21 rho N2. In this equation rho is common, so we take rho it's a common one. Rho into B12 N1 minus B21 into N2 it's equal to A21 into N2, and we calculate the equations of rho it's equal to, so A21 N2 divided by B12 N1 minus B21 N2. In this equation we calculate A21 B21, so we take a separations and A21 into N2 B21 to N1 minus B21 N2 we take an equal equations of equations, so we have multiple and divided in the equations. So B21 divided by N2 whole value, so B12 N1 divided by B21 N2, and opposite side we have calculated to B21 divided by B21. So N2 N2 are cancelled, B21 B21 are cancelled. So B12 N1 divided by B21 N2 minus 1. From Boltzmann distribution law, the relative populations were photon energy is equal to h mu E2 minus E1, and N1 divided by N2 is equal to e power h mu divided by kt. This is the Boltzmann constant distribution law, where K is Boltzmann constant, T is absolute temperature. So we input the equation rho is equal to A21 divided by B21 into 1 divided by B12 divided by B21 e power h mu by kt minus 1. According to Planck's theory of radiation, the energy distribution is given by rho is equal to 8 pi h mu cube divided by c cube into 1 divided by e power h mu by kt minus 1. The comparing equations of 4 and 5, a21 divided by b21 into 1 divided by b12 divided by b21 e power h mu by kt minus 1. It's equal to 8 pi h mu cube divided by c cube into 1 divided by e power h mu by kt minus 1, where b12 is equal to b21, it's equal to b. Both are equal. Energy states are upper state to lower state to upper state are equal. So A21 divided by B21 is equal to 8 pi h mu cube by c cube. So A is equal to B. So in equation 6 we know that B12 B21 are equal to B. So A21 A1 are equal to A. So A is equal to B 8 pi h mu cube by c cube. Equation 6 and 7 known as Einstein relation and 8 gives the relation between A and B Einstein coefficients. Thank you guys. Thank you.